10A number 1, in a certain class, midterm scores range out to 60 with an SD of 15, or average out to be 60 with an SD of 15, as do scores on the final. The correlation between midterm scores and final scores is about 0.5. Estimate the average final score for the students whose midterm scores were in those areas. So we start off, and we know that the average of the midterms, so this will be the midterm axis, and this will be the final axis. And the average is 60 with an SD of 15. And on the final, the average is also 60 with an SD of 15. And what does 0.5 look like? Egg. It's egged, and is it positive? Is it going up or is it going down? Going up. So this is the very center of that egg. There we go. Something like that. Okay, we have egg-shaped. So the SD line is the line that divides the egg into two equal halves, and it goes through the center, the point of averages. So this point right here is 60, 60. And any person who lies on that line is equal SDs from the point of averages. So somebody who scored 1 SD higher on the midterm and 1 SD higher on the final would land on that line. Somebody who was a third of an SD below average on the midterm and a third of an SD below average on the final would also land on that line. Okay, so the slope of that line is simply the SD of the y's divided by the SD of the x's, rise over run. In this case, because the x and the y have the same SDs, the slope of the SD line is 1. And it might seem to you that making predictions on future scores would be done using the SD line. But we decided that wasn't the case. Now, that was a long time ago. Do you remember why? So, one of the questions asks, if you get a 75 on the midterm, what would you expect to get on the final? Well, that's 1 SD, so right here is 75. If I look at all of the people who scored 75 on the midterm, does this seem like a good prediction for how that person would do on the final? No, it looks too high. Do you guys see that? Our best guess needs to be the average. And the average of this column is like right there. My column's a little low. There we go. Why does that happen? Well, there are two things at work here. Tall dads usually have tall sons that are shorter than they are. Why is that the case? Yeah, if tall dads had taller sons who had taller sons who had taller sons, and if short dads had shorter sons who had shorter sons who had shorter sons, then we would end up with two races of humans. People that are getting smaller and smaller to 0, and people that are getting taller and taller to infinity. And that doesn't happen. So tall dads usually have tall sons, but their sons, on average, are shorter than they are. That's just what happens. It's called regressing towards the mean. The people on the edges work their way back toward the middle. It's just a natural effect of football-shaped graphs. So if you score 75 on the midterm, are you expected to score 75 on the final? No. You're expected to do better than average, but slightly less than you did before. Now, will some people do very well on the midterm and very well on the final? Yes. But if we look at the people who do very well on the midterm, most of them will not do as well on the final. That's just a natural progression of the bell-shaped curve. If X is bell-shaped and Y is bell-shaped or normal curve, then that's just what happens. So if we look at this person who scored 75 on the midterm, and we track over their score on the final, it's not going to be 75. Because of all the people in this column, our best guess is the average. And the average does not lie on the SD line. It lies on what we call the regression line. And the regression line in this case is going to look like that. And it happens to go through the center of every single column. So if I draw a whole bunch of columns, you'll notice that that regression line runs right through the middle of all of those. Okay? You guys remember this? So, how do we predict what your score on the final is going to be if we know that your score on the midterm was 75? So you can do it backwards. We're going to do it forward, but that's kind of the idea. So we need to figure out how much better did you do than average. What was your score compared to the average? What was your midterm score compared to the average? How much higher were you? Okay, and let's say 15 points. Okay, but do we really care about points here? No. 15 points is equal to 1 SD. Does everybody get that? So you scored 1 SD higher than the average, which means we predict that you are also going to score 1 SD higher than average on the final, but something else is happening here. We have to times it by R. Does anybody remember why? Right. Our estimate is going to be wrong. So this estimate right here is wrong. Why is it wrong? Because our graph is egg-shaped. And the more egg-shaped the scatter plot is, the further your prediction is going to be off. Now, what if all of the scores were in a straight line? Then our prediction is going to be perfectly accurate. 1 SD on the X and 1 SD on the Y is going to be perfect. If R was 1, then the SD line prediction is correct. But the more egg-shaped the football becomes, the more inaccurate the SD line becomes. So if my football were shaped more like this, then look at this little column here. Does the SD line pretty accurately hit the middle of that column? Yeah. But as the football becomes more and more egg-shaped, then this right here stretches out and your prediction is more incorrect. So when we do our SD difference and our SDX difference and our SDY difference, we have to remember that our prediction is going to be wrong. How far off is it going to be? And the answer is it's 50% off. The increase is 50% off. So instead of going up 1 SD, which is 15 points, we're actually going to go up 15 points times 0.5, which is 7.5. What does that number tell me? That's how far, what your score is compared to the average of 60. Add that on, and the answer is 67.5. So what that's saying is Let's say I've given this test year after year after year after year. And every year, well, if you take all the years and you combine them together, the average on the midterm is 60 and the average on the final is 60. They both have an SD of 15. So halfway through the year, we take the midterm and you score 75. My best guess for your score on the final is 67.5. That's my best guess. Now, some people will score higher than that, but most people will score less than 75. That's just how the normal curve works. Okay? Now, how accurate do we think this is going to be? Not right, not very close, because the R value is really small. 0.5 does not give us a very good prediction. But of all the predictions out there, this is the best one. And if I took every kid who scored 75 on the midterm for all the years that we've given this test, and I averaged their scores on the final, the average of their scores would be 67.5. So every kid that scored 75 on the midterm, I averaged their final scores and I would get 67.5. So this curve actually does two things. It allows us to see what happened in the past, right? Everybody who scored 75 averaged 67.5 on the final. It also tells us what we expect to happen in the future. Okay, now that I've made a horrid mess of this, let's see how much of it I can erase really quickly. All right, the next one says 30. So 30 comma what? Well, 30 is how far to the left? 2 SDs. 30 is 30 units away from 60, and 30 units in SDs is 2 SDs. So 2 SDs. So I need to go down 2 SDs, but I'm going to go down too far. How much too far? This much. So instead of dropping 30, which is 2 SDs, I'm going to drop half of that, and I get 15. What does 15 tell me? That's how far below 60 you're expected to score. So 45. If you score 30 on the midterm, my best guess is that you will score 45 on the final. But do we expect this to be very accurate? No, because this is very, very egg-shaped and the scores are all over the place. But of all the students who score 30, the average on the final should be about 45 for all of those kids. Okay, what about 60? How many SDs is 60 from the average? 0. Which means the best prediction is the other average, which is 60. Now, that is the essence of chapter 10. That's pretty much it. Okay, I mean, there are little add-ons that we have to do, but that's pretty much chapter 10. All right, for men age 18 and over in Haynes 5, we have an average of 69 inches tall and an average of 190 pounds. And our R value is 0.41, which is really egg-shaped. Something like that. So here's my point of averages. Here is my SD line. And the SD of the X's is 3. And the SD of the Y's is 42. So estimate the average weight of men whose heights were, A is 69 inches. If you come to me and say you are 69 inches tall, how much do I think you weigh? 190 pounds. That's my best guess. I'm probably wrong, but that's my best guess. Okay? I might be way off, but of all the guesses out there, That's the best one. Okay, 66 inches. So we go from the point of averages and we go left, how far? 3 inches. So we go left 3 inches, which is 1 SD. Because that is the SD of my x's. Which means I need to go down 1 SD. But how far is 1 SD on the y-axis? 42. And when I go down 42 pounds, I went too far. How much too far? Well, I need to multiply that by my R value. So I take 42 pounds, times it by 0.41, and I get 17.22. What does that number mean? That's how much less this 66-inch man is expected to weigh below average. The average is 190. So 190 minus the answer gives us an estimate of 172 3/4 pounds. Do you guys get that? Yeah? Okay. What about a man whose height is 24 inches? How far to the right is 24 inches? 45, right? So this man is 45 inches shorter than average. What is that in SDs? 15 SDs. Okay, so I'm going left 15 SDs, which means I need to go down 15 SDs. So 42 times 15. But that's too big. What do I need to do to that? Times it by 0.41. And this person weighs 258 pounds less than average, which means he weighs negative 68 pounds about. Okay, anybody see a problem with that? It doesn't make any sense. Why? Well, the answer, we ended up with negative 68 pounds. Of course, that doesn't make any sense. But what's wrong with this? What's that? Nobody is that short. How do you know? What is it about this setup that guarantees that nobody is that short? And the answer is, it's this right here. How many people are 15 SDs away from the average? Nobody. Because if somebody was that short, what would happen? Good. The SD would not be 3. It would be much bigger than 3. Do you guys get that? Nobody is 15 SDs away. The chance of somebody being 15 SDs away is like 0.00000000001 or something like that. It's unbelievably unlikely. Okay? You would have to have trillions and trillions and trillions of people in order to find one that was that way. And if somebody was that far away, then the SD would be bigger than 3. Because that person would pull the SD far away from the average. So I kind of just ramrodded this and didn't ask you any questions until we got to the end. But if you see 15 SDs, you got to say, no, something's wrong. This is not a normal curve. Or the SD value is wrong. Because how far can we get off the SD before we start to get skeptical? Outside 3, we start to say, I'm not quite so sure about that. Once we hit 5, the calculator quits caring. So if there are people between 3 and 5 SDs, we get really skeptical. Anybody outside of 5 SDs, we simply don't believe it. That doesn't happen. Okay. So the next one, what about a man who is 0 inches tall? You're going to have the same problem. You're going to end up with, what, 23 SDs? And that person will weigh like negative 400 pounds or something. I don't know. But it doesn't make any sense. So that can't, that doesn't really happen. All right. Number 4. So we have women in 2005. We're graphing on the x-axis education levels, which is an average of 14 years and an SD of 2.4. And then on the y-axis, we have income, which is an average of $32,000 with an SD of 26,000. And we have an R value of 0.34. So just looking at these numbers, does it appear that there is a correlation between years of education and income? Is there a correlation between years of education and income? Yes. How would you rate its strength? It's positive and it's weak, quite weak. So, do women with more education make more money? Yes, but it's a very weak association. Does education cause women to make more money? That would depend on where this information came from, right? Can you do an experiment where you send people to college and see if they make more money? Probably not. What could a confounding factor be? Why might women with more education make more money and it doesn't really have to do with their education? Okay? Women who get married young and have kids and never go to college and never get a job don't make very much money, right? So they're going to pull the average in their direction. Okay? Why might women who get an education make more money, but it doesn't necessarily have to do with their education? Maybe they don't have kids. Okay? Do homeless women have a lot of education? Not usually. Do they make a lot of money? No. So the type of person who goes to college might be more prone to get a job. That could be a confounding factor. So this is the one that really drives me nuts. Somebody will be talking about scholarships and they say, if you go to college, you will make on average $15,000 more per year than you would if you don't go to college. And that is crap. Because who is in the non-college realm? Mentally disabled people are in that, right? People who cannot function without help are in the didn't graduate from high school category or the didn't go to college category. People who don't want jobs. So what we need to look at is, in my opinion, when you go to college or when you graduate high school and you go to college, what about the people who have a sound career path that doesn't include college? I'm interested to see how much money they make. Because simply categorizing people into graduated or didn't graduate or went to college and didn't go to college, that's a terrible group to look at because it's not random. People put themselves in their own categories. And the reason they put themselves in that category might have more to do with their income than whether or not they went to college. Does that make sense? Okay. A man or a woman who decides to be a stay-at-home parent because they're okay with that, that should not count against the people who decided to go to college. Does that make sense? So when you hear those statistics, just roll your eyes and ignore them because we are telling every kid that everybody needs to go to college, and that is flat out wrong. It's flat wrong. College is the path for some people to get certain jobs. But other jobs, a traditional college is not the place to go. A trade school, an on-site training, on-the-job training. There are lots of good paths that don't include college. Okay, sorry, that's my soapbox. So we are very, very egg-shaped. It's nearly a circle. Okay, here's my point of averages. Here's my SD line. Estimate the average income of those women who have finished high school but have not gone on to college. So they have 12 years of education. What is the expected income of a high school graduate who does not attend college? Okay. So we need to go left 2.4. Nope. Not, sorry, just 2. We need to go left 2 years. How far is 2 years? Well, 2 years divided by the SD of 0.24 is 0.83. So we go left 0.83 SDs, which means we need to go down 0.83 SDs. And the SD of the Y is 26,000. So times 0.83. But that is going to be too far because the average of that column is above the SD line. And we find that by multiplying our drop by the R value 0.34. So I times this by 0.34. And what does $7,366 tell me? That's how much less we would expect this woman to earn than the average of 32,000. And we get 24,633. Do we expect this number to be very accurate? No. Why? The egg is 0.34, which is a terrible predictor. Don't go predicting with an R value of 0.34. It's our best guess, and that's the number that some college admissions person is going to tell you, right? When they report this, what they do is they find, oops, not that line. They find the equation of the regression line, and let's see what it would be. It's probably like 1,000x plus 14, so 32 minus 14 is, what would that be? 18. So the equation of this regression line is about 1,000x plus 18,000, which means if you don't go to any school, you're expected to make $18,000 a year. And for every year of education you earn, you will make another $1,000. So if you go to school for 16 years, which would be a 4-year college degree, times 1,000 plus 18,000, then you would expect to make $34,000 your first year in your job. Does that make sense? But how accurate is that number? It's terribly inaccurate because look at that. Right here is $34,000. But some women earned $80,000 and some women earned $2,000. And nobody tells you that. All they do is give you this information right here and say, this is our best prediction. Now, that's not a lie. It is our best prediction. But we don't even remotely consider that to be accurate because the R value is very, very small. Does that make sense? You're starting to understand how you can lie to people with statistics and still tell them the truth? Well, rest assured, it gets worse. All right, number, what are we on, 5? Suppose R equals -1. Can you explain why a 1 SD increase in X is matched by a 1 SD decrease in Y? If R is -1, then what does the graph look like? It's sloping down and all of the points are in a straight line. So there is no frisbee. It's just a straight line with points on the line. So if I go up 1 SD for the X's, and I go down 1 SD for the Y's, I have to multiply this by what number? 1. Because my prediction is perfect. There's no variation. So in that case, we don't need to multiply by the R value because it's 1, and all the points are in a straight line anyway.